So today I'm going to be talking about continuous delivery with Puppet, and we'll probably cover a pretty big range of things over the next half hour or so. If you have questions, it would be great if you just save them till the end. I normally don't care, but I can't see, so I'm going to look like an asshole. Oh, am I allowed to swear? Whatever. It's computers, I can swear. So yeah, I'm Sam Kottler. You may know me from such ditties as Ruby Gems and Bundler and other stuff. One quick public service announcement before we start. Dubfar and Dominic Cleal and I have been maintaining the Puppet 2.7 branch for the past year. A week from today, it's getting end of life. So if you're still running 2.7, you're going to be doomed in a week, so upgrade to 3, please. Yeah, get that done. You have 7 days, 5 work days, so. I work at DigitalOcean. We're a public cloud hosting provider. We recently became 4th biggest in the world, which is pretty cool. We're hiring. If anyone's interested in that, I'll be around. Just come talk. There are a few other people from DigitalOcean here as well. And we're kind of always looking for people to work on infrastructure stuff. So that's the plug. So I guess before we start actually talking about this, I think it's pretty important to talk about why we suddenly care about this thing called continuous delivery and continuous integration. And I think there are kind of a few pillars that fall into the topic as a whole and why we actually care about it on the methodology side. So the first is this idea of deliverability. Also, none of these are real words, I don't think. I just made them up because they were cool. But I think the first thing is this idea of deliverability, right? The ability to actually push code and infrastructure changes out into production in a reasonable manner and actually be able to deliver on the promises that we make to the companies that we work for and the engineers on the other side of the wall. If you have a wall, that's unfortunate, but the promises that we make and being able to actually give people the other side of those promises, right, which is actually being able to put things into production. The other, which is heavily tied to the idea of deliverability, is the ability to make change, right? The ability to ship changes to the environment, the runtime, the operating system, all the bits that systems people care about. And when we lose that ability, there are a bunch of things that happen, but the worst thing, in my opinion, is this idea that you become fearful of change. If you're not constantly changing things, change becomes harmful and painful. And Gene talked about that a little bit, where it really starts to hurt to introduce change. It really starts to become painful, and you're constantly afraid of what's going to happen. So if you're always changing stuff, if you're always kind of touching on the idea that change is something that's going to happen and it will happen, and you have a way to actually push out that change, it's a lot less scary. And something that's come up recently, I think, which is pretty interesting, is the idea of immutable infrastructure. And there are a few people who have been kind of thinking about this harder than others. And the CoreOS folks, for example, are really thinking hard about this, as well as the people who work on Docker. And they kind of have this idea that instead of actually changing what lives on the machine, you change the machine, which is kind of subtle, but the fundamental idea behind it is instead of altering a running instance, you just create a new one, for example. Or instead of altering a Docker container, you just get rid of it and spin up a new one. And the infrastructure that's powering those systems is becoming so fast, right? The Linux boot process, for example, is becoming so fast at this point that you can definitely do that in a reasonable manner. Someone troll me about systemd after this, because I'll have that conversation. But immutability for stateless services, things like APIs that talk to databases. The database holds state, and the API doesn't have any state. It just connects to the database server and makes a change. And I'll talk a little bit more about this in a bit, but I think there's an interesting thing here where there's a false dichotomy between your ability to introduce change and state. And we'll talk more about that. And the what of how we actually deploy this stuff, how we actually get change out into production, is really just a subset of how we do it. I think there are all these things like images and packages that are really great, right? And people like Jordan Sissel have made packaging so easy at this point that you have no excuse anymore. It doesn't hurt to write, like, you're not writing specs, you're not building Debian folders. Like, none of that stuff exists anymore. FPM is a miracle, so thank you, Jordan. He's not here, but hug him or something tomorrow. And then we have this whole other class of things, which is appliances. You know, I'll talk more about building appliances and tools around appliances in a bit, but I think that appliances they kind of died out for a little while, but I think they're going to come back as we start building more stateless services and kind of push state into centralized systems and try to build, you know, edges of statelessness. And as we think really big, we think about entire environments, right? We think about development and staging and production and, I don't know, QA, if that's a thing you do, and, you know, all that kind of stuff. And as we think about building entire environments, all of this stuff becomes critically important because without the ability to introduce change, without the ability to spin up a new environment or test changes or do anything like that, it becomes very painful. So I think environments and thinking about the idea of an environment as a whole, you know, as a unit and it moves together and all of those kinds of things is really important. And fundamentally, build and configuration are becoming the same thing, right? How many engineers who work on solely build or solely configuration management or whatever, you know, and don't work at really big companies, I think is a pretty strong testament to this kind of thing, where fundamentally the build relies on the configuration and the deployment relies on that config being correct and in place. And there's this idea that we have of two-stage deployment, which is the first is the configuration goes down onto the machine. It sets environment variables that you need for your runtime. It, you know, writes out an upstart or systemd service unit. And, you know, all that kind of stuff happens below the code. But increasingly, especially languages like Go are starting to push the idea that you should store configuration in the binary that gets deployed. And single statically linked binaries are pretty interesting as an idea, I think. They've obviously been around for a long time, but Go's kind of introducing them again. And I still think getting rid of this two-stage deploy that we've had for so long will be critically important to being able to deliver things quickly. Yeah, so on immutability, I mean, I think to some extent immutability is a lie, but at the same time, I think that it makes sense in a kind of very vague way. If you can change things quickly and you can change what lives under the code rapidly, it can become meaningful. The problem with immutable systems at kind of when you're not greenfielding a project is that stateless systems hold state. So, you know, a lot of people think of like big memcached clusters as stateless. But in reality, they hold enough state that you know that your service is going to go down if you know, your big TWEM proxy cluster goes away. Or your, you know, your Redis server, which just holds queuing data, it still has state in it, right? Like, you know, just because you're storing pseudo-ephemeral information in there doesn't mean that you can lose that thing, right? So as we kind of introduce the Brownian motion idea of immutability, we also have to be careful as to understand the state of the system and to be able to push changes to that state without affecting the entire system. I think as we increasingly spend time working on configuration and build as one, assuming that's kind of an idea that takes off and becomes bigger than a few communities that are focusing heavily on it right now, I think we'll see a lot more or a lot fewer systems that kind of separate the idea of cluster. And I mean, we've been seeing this for a long time with the evolution of how cloud services have been working, where, you know, lots of people are building services that work in a way. I think React's a really good example, where they're fundamentally thinking from the ground up about how to build systems that can sustain, you know, huge impact across lots of data centers and stay online. And people like Kyle Kingsbury are doing a lot of really interesting work on state management and kind of looking at network partitions and all these things that we deal with every day when we're running big distributed systems. So despite what you may have heard about Docker, like it's not going to solve all your problems right now, sorry, deal with it. There are huge amounts of kind of uncharted territory in the land of orchestration. And as we think more about the way orchestration works, as we think less about individual systems, this is going to be solved. This is just a time issue. There are lots of very cool projects out there that are increasingly thinking about how to solve orchestration. Surf and Console and etcd. Google has been thinking about this forever with Borg and increasingly and recently Kubernetes. And so all of those things are going to become incredibly important to the future of being able to actually, and Mesos as well, which came out of Twitter and is now an ASF project. But all of those things are going to be the future of kind of building these really large distributed systems. But orchestration is not a solved problem, right? Puppet and Chef and Ansible are inherently bad at doing real-time orchestration, right? When this node changes, change this node right away. It just doesn't work. And so I think we're going to start seeing a new class of tools that live above configuration management and below applications, or are tightly integrated into applications that solve this kind of problem, where you have a big cluster of machines, and as state changes, you need to rapidly alter where HTTP traffic or MySQL or Redis or whatever goes. And the result of these systems is often binary, right? We have some kind of large-scale change, and the result that we produce is actually just this one thing. So it could be like a disk image or a package or whatever. And so then that's what we push out. And looking at static linking, I think, again, will solve a lot of these problems. But as we think about testing, back to test land, as we think about testing, single node convergence is where we've started, right? There's a lot of cool projects like Test Kitchen, which came out of the Chef community, which we're increasingly using. BEAKER, which Puppet Labs have been using internally for 3 or 4 years and have recently open sourced. And a few other tools. I mean, you can even do this with just Bash, where you just run Puppet on a node and see if it converges. But making sure that the machine takes the state that you expect is kind of step 0. Doing large-scale testing is really hard, and I don't think anyone has effectively solved it yet. But single node convergence is where we're starting. If you haven't had a chance to check out Test Kitchen, it's pretty impressive. And I think, tools like that will be incredibly important going forward. But ultimately, our production systems are built out of lots of other systems, right? We generally don't run homogeneous systems in production, right? We have MySQL and we have application servers and JBoss servers. Shows that I worked at Red Hat. JBoss servers, and we have lots of different roles and different kinds of machines. And in order to get change out onto those machines, we have to actually make sure that they can all converge into one thing. And we don't have that done very well yet. I think as the orchestration problems become less and less hairy, and we have better primitives to build on top of, this will become more of an issue than it is right now, because the actual ability to spin up an entire new environment for most organizations is so limited right now and so interdependent on nodes, right? If you're expecting on one node to have an exported resource, if you're expecting on one node to have an exported resource to add a check, and then your Nagios server relies on that, you need those 2 nodes to both be online before you can have Puppet start managing those resources, because otherwise you end up in conflict. And really, the highest level that we're going to get in kind of modern day infrastructure testing is multi-node orchestration testing, where we can bring up an entire environment. The environment knows how to converge itself, and then we can actually run the tests on it to make sure it's functional. As I said, I think this is a pretty good example and a simple example that we can all relate to. The kind of systems that we build around monitoring often are reliant. So like this exports a Nagios toast resource, and this collects it. So for example, if you had like an app server and then a Nagios server, you would I think a lot of people in this room have done this if you use Puppet, but you run this on the, node is the client, and then this is run on the actual monitoring node. And so I think ensuring that these work correctly together is the next step. We're not that far away. I think in the next year we'll have this around. But fundamentally, we want to run systems that work well both in isolation and together. The single node convergence testing that you can do with Test Kitchen and Beaker works well because fundamentally it works in isolation, right? And systems in isolation are a lot harder to break. And at the end of the day, we actually don't care about systems. Like, systems really don't matter to what we're delivering. We care about what's running on the systems. We care about what the systems do. And we have deliverables, right? We have, like, all these things that need to happen. And I think in order to remember why we need testing and why it's it's critical to have these systems in place, this is the core principle of, like, why we do testing. Humans are bad at repetitive tasks, and also humans are kind of generally bad at focusing on a thing for a long time. And I'm not talking about, like, a day. I'm talking about, like, focusing enough to remember that you can make, these are all the places where you use that variable that you just factored out. Or, these are all the systems that look like this. And we're just bad at repetitive tasks, especially around memorization. And so cutting those kind of out of the curve, I think, and getting systems that we can actually use to prevent human damage to computers and hopefully computer damage to humans is a good thing, especially because computers will hurt you. So the most basic thing here is fundamentally, does the system work? And to dive into some tools, now that we have the theory down, I think things like RSPEC-PUPPET, Rajek is around, give him a hug, he'll love it. Things like RSPEC-PUPPET that let you do behavior-driven testing on your Puppet code are incredibly powerful for asserting that you're building systems correctly, in that, like, what you expect to be in the catalog actually is in the catalog. If you haven't checked it out, it's an incredibly powerful tool. And a lot of the things I'm going to be talking about, Gareth R on GitHub has a skeleton module project, which is a great starting point for a lot of modules. So I'd highly recommend you check it out. So RSPEC-PUPPET lets you do behavior-driven testing on Puppet. And it's great for those modules where you're supporting 8 different OSs and you want to make sure that the right package gets installed on the right one. It doesn't apply configuration to the node, it inspects the catalog. And then there's this kind of next level tool, which I talked about, like Test Kitchen and Beaker, where they actually apply configuration and then inspect the state of the VM or whatever system you use to spin it up, on VirtualBox or VMware Fusion or wherever. And tools like Beaker are powerful for ensuring that the state of what your module or modules is going to be actually becomes. And that's critically important because you can test individual pieces, but as you kind of are building out nodes, it's, especially with Puppet, where it's not declarative, this can become incredibly painful down the road. And yeah, I think it's just great to have Beaker there and be able to know that your system will converge from scratch out in production, because it's a huge pain when things work, but then you spin up a new node and Puppet doesn't apply cleanly. And then there's this one. You might have run this before. I think fundamentally, when we look at how infrastructure changes affect us, applying the configuration of those nodes again is a really interesting and kind of obvious, well, incredibly obvious way to measure and detect change. And along these lines, I'll talk a little bit more about this, but I'm a pretty big fan of running Puppet via your monitoring system. So you can run Puppet as part of a passive check. And if your configuration is being incorrectly applied or it doesn't cleanly apply, like that should raise a red flag in your environment. Not having change management happening, audit, control, and all that kind of stuff that you probably want to use Puppet for, even if you don't call it those words. I think having that stuff happen and calling someone if it doesn't is good because it means something's wrong. And to prevent that from actually, to prevent it from ever becoming kind of a big issue, having all of these other test methodologies in place first is a good preventative measure, I think. Then there's this next thing which focuses on delivery. How do we actually get the Puppet out to the master, or if you're running in masterless mode, how do we get Puppet code out to nodes where we can then apply it? I'm going to be mostly talking about deployment systems for Puppet and patterns that I think work well, but there's also kind of another class of tools, which is using Puppet for installers, and I think those are kind of equal importance, especially as the appliance market, I think, is coming back to some extent. So the first is old trusty Capistrano. Been using this thing for too long, and I think that using a tool like Capistrano that inherently has the ability to both push change and roll back change is great. As we look at the future of Capistrano, there have been recent changes that I'm less than pleased with, but I still think it's an interesting tool. It still works well. You probably want to use Capistrano 2. 3 is, whoa, metaprogramming. Yeah. There's a new cool tool called R10K that Adrian Thiebaud has been working on that I'm pretty impressed with. It's still in the early days, but I think this will kind of shape up, and Puppet Labs have increasingly been saying that it's going to become kind of the canonical deployment method. It supports lots of nice features, like, for example, being able to do environment per branch. If you're not familiar with environment per branch, it's essentially the idea that every time you push a branch into hopefully your Git repo, but if you're not using Git, that's sad, but fine, just use version control. It's the idea that every branch you push should create, as long as that branch exists, should create a new environment on your Puppet master. And it's really powerful for being able to apply changes and test that change on one node, canary it out in a different environment, and then flip that node back into production if you can, or roll it forward, however you do it, reinstall it. But the environment per branch pattern is incredibly effective, even at scale with massive teams. I used it with a team with 100 people, and it worked pretty well. You just have to figure out a good branch naming scheme. So yeah, I think R10K is kind of where we're headed here. As I said, it's young, but hopefully soon it will kind of fit the mold of what people have been waiting for, especially in Puppet 3.6 Plus. It makes a lot of sense because the way environments work changed so that they can be loaded off the disk. And the last is a tool I worked on while I was at Red Hat called KAFO. I worked on the Foreman and Kottler projects there, and in case you can't tell, there's Ka and Fo, which are the first 2 letters of each project. It's an installer tool set around Puppet that is made to build kind of like it's made to build the kind of configuration and kind of question system that you would expect, like an installer system, where you can go through it and you can provide it a bunch of like answers. These are set off parameters, so it inspects the class, and you can look at other parameters as well. But it populates those based on a commenting scheme and some other stuff so that you can like ask, what's the FQDN of this installation going to be, or what's X, Y, or Z going to be, and then make changes based on that and set parameters. So it's heavily focused on, if you've ever installed Foreman, it's heavily focused on a system that kind of looks like Foreman, where you're going to deploy one or a few of them, and then that thing is just going to kind of sit there and wait for work. It's not built for like, have your sysadmin go through the installer. Like, don't. That's terrible. And then, as I said, making sure that it actually works. We talked about this already. Running Puppet via monitoring systems. It sounds really weird, except when you do it and it works kind of well. Like everything, I guess. But running Puppet via your monitoring system, whether you use Nagios or Sensu or Isinga or whatever, is definitely interesting and works pretty well even at large scale, as long as you're not constantly breaking things. And then lastly, another Roject special is the Puppet lint tool, which is great for kind of checking if your Puppet code kind of applies to style guides and inspecting what the state of your code versus kind of what the desired state in terms of functionality, or not functionality, in terms of format would be. So just to wrap up before questions, we want to integrate changes quickly, validate them, make sure that they work, and then ship them. That's all I've got. One other quick thing before questions. There's an Isinga camp if you're interested in that on Thursday at GitHub's offices. I'm going to be talking about how we use Isinga at DigitalOcean, and there'll be some other talks as well, and I think it will be pretty cool. There are a few spots left, so come by. Questions? Is there someone with a mic? There we go. Anyone have questions? I can't see anything. Oh, over there.
Could you tell us a little bit more about KAFO in terms of, so it's like unto Foreman? Is that what you said?
Sorry, can you say the last bit again?
You said KAFO is like Foreman. Can you tell?
No. So KAFO's the installer that we built for Foreman, and it basically, you run it and it inspects based on a bunch of Puppet modules. It inspects parameters on classes, and then lets you kind of one-off set them and change them, and then do the install.
Okay.
So it's just meant to run Puppet with a bunch of class params, and has like some nice colored output and stuff like that.
All right, cool. Can I ask another question? Is that cheating?
Do it.
Okay. I don't know if this is the right venue to ask this, but I've been looking for a tool like Foreman, but something that actually manipulates like virtual private cloud stuff in Amazon that is complex and requires the API to actually manipulate. And I've been able to automate this all like myself through my own coding, but I was just wondering if there are any projects that you're familiar with that already attempt to solve this problem.
Not off the top of my head. We had, I mean, Foreman supports provisioning on AWS, but it doesn't support like complex resource management stuff. There's been talk of doing that for a long time, but it's actually really hard, and AWS's API will make you want to do nasty things to humanity. So, yeah.
Okay. I know the people that are making Vagrant are coming out with something that attempts to solve the problem, but it's a beast. So I don't know.
Yeah. There's Terraform, which HashiCorp built, which is pretty nice for kind of doing like the, give me this and then manage interconnected state via graph. Any other questions? I guess that's it. Thank you. If you want to contact me, these are the ways to do it. I'll be around. Thanks.